First, a concept of the work. So in thermodynamics, the work we will usually use the terminology work involved. By definition, work involved is equal to minus PdV. Next, based on the conditions that are being maintained during the expansion or compression of the gas, we will use different terminologies for the description of the process. For example, if the expansion process takes place at constant temperature, it is called isothermal process. Next, during the expansion of any gas, if the system and surroundings are in equilibrium at every stage, hence it is described as the reversible process. Therefore, isothermal reversible expansion of the gas means the expansion of the gas at constant temperature when the system and surroundings are in equilibrium with each other is called isothermal reversible expansion of the gas. First. Next, see, for expansion to take place, what is the basic requirement for a gas to be maintained? Say for expansion, the pressure for the expansion to take place, the pressure of the surroundings must be slightly less than the pressure of the gas. Therefore, for expansion, P external must be less than the P internal. Next, in reversible process, in reversible expansion process, P external, that means P external must be less than the P internal. Therefore, P internal minus dP, where dP tends to 0. That means dP tends to 0 means the pressure difference between the surroundings and system must be negligibly small. This negligibly small magnitude in thermodynamics is usually represented as infinitesimally small. Therefore, dP tends to 0. So, when dP tends to 0, P external is almost equal to P internal. Next, according to the ideal gas expression, for ideal gas, PV is equal to nRT. Therefore, pressure of the gas, that means P internal is equal to nRT by V. P is equal to nRT by V. Therefore, in place of P internal, we can substitute nRT by V. P internal is equal to nRT by V. Next, therefore, work involved at a constant temperature. Work involved at constant temperature. nRT by V. Since the process is reversible, therefore the number of stages in which expansion takes place between V1 and V2 is total number is infinite. Therefore, number of stages required for expansion, number of stages required for expansion from V1 to V2 is infinite. Therefore, work involved in infinite number of stages can be obtained by integration of above expression as follows. Therefore, work involved is minus nRT dV by V. It is equal to minus nRT ln V2 by V1. Next, since V2 is greater than V1, therefore the expression will remain negative. The expression will remain negative. If the final expression is negative, then we can say the gas is doing some work. When a gas do some work, its internal energy decreases. When the internal energy decreases, then to represent the decrease of internal energy, we will always use the negative sign. Therefore, since the expression will remain negative, if the expression remain negative, that shows the energy is being spent off by the gas. The expression will remain negative. Therefore, the negative sign represent the spent off energy. Therefore, whenever if you want to calculate the work done by the gas under isothermal reversible expansion process, this is the expression. In this expression, N is the number of moles of the ideal gas participating, R is the universal gas constant, T is the absolute temperature on absolute scale, V2 is the final volume of the gas, V1 is the initial volume of the gas.